All right, everybody, what is going on? We got another video here. This video is on antiderivatives. Now, what I want you to keep in mind in this video, we're not really going over procedures of how to find antiderivatives. This is just kind of giving you the basic idea of what antiderivatives are. So, it's good to watch this section, but in the next several sections, we're going to be learning techniques. We'll have formulas and all that good stuff. So let's go ahead and get started on this video. And basically it's just, I think, five examples. So it says find a function for which the derivative is 8x cubed. So that's antiderivatives. We have this function here, 8x cubed, and we want to know what did we have to take the derivative of to get 8x cubed. Well, whatever function that is that we have to take the derivative of, that's going to be x to the fourth, right? Because the 4 would come down, right? The 4 would come down, and you would subtract 1 from the exponent, which would leave the 3. So we know it's x to the fourth, all right? And then when we bring this 4 down and multiply it to whatever number is in front of x, that has to equal 8, okay? So what would have to go here? Well, that's what we need to find. It's going to be some number a. So when we bring the 4 down, that's going to give us 4a x cubed if we take the derivative of this, right? And what happens? Well, this 4a here, let me do that in a different color. This 4a here, what does that have to equal? That has to equal this 8 right here. So we know 4a has to equal 8, so a is equal to 2 when we solve. So that number here in front has to be 2. And so our answer would be 2x to the fourth, and that would be the antiderivative. And you can check it real easy. Bring the 4 down. 4 times 2 is 8. Subtract 1. That would be 8x cubed, which is this. All right. All right. Let's look at the next one. Find an antiderivative of v squared plus 2v. All right. So let's just take it term by term. So that's going to be v cubed. Okay, so the next thing we got to ask ourselves, what do we need in front of v? What does this coefficient need to be? Well, remember, when I take the derivative of this term, I've got to end up with v squared. So the 3 comes down, subtract 1. That'll give me my squared for the exponent. But what number is in front of v right here? It's a 1. So 3 times what number gives me 1? Well, 3 times what? 1/3. You see that? All right. And then plus, now let's look at this one. Okay. What do I take the derivative of to get 2v? Well, this exponent is a 1, right? So we know that's going to be v squared. Okay. So the 2 comes down. 2 times what is going to give me 2? Well, 2 times 1, right? And so that's 1/3 v cubed plus v squared. All right. Now, the other thing that I want to mention real quick before we move on is finding these antiderivatives. And I did not write it on these problems, but we will when we get into the next section and as we go on into the other sections, we will write it. There's an arbitrary constant that you add to these things, a plus c. Okay, I'm not putting it in these. We're just learning. Okay, what do I have to take the derivative of to get this? But note, but I want you to know this, that this could, like the antiderivative for this 8x cubed, yeah, it's 2x to the fourth, but it could be 2x to the fourth and plus 1, or 2x to the fourth plus 2, or 2x to the fourth minus 3, minus 5. There could be a constant here, because remember, if this is some constant, say just some constant c, well, what would be the derivative of this whole thing? Well, that's 8x cubed plus, and what's the derivative of a constant? 0. But we'll talk about that more in the next video. Okay? All right, so let's look at this one. So find an antiderivative of the function f of x equals the square root of x minus 2x cubed. Now, the first thing we want to do here is we want to rewrite this function here. This square root of x, we want to write that as x to the 1/2, and then minus, and this right here I want to write as 2x to the negative 3. Okay? All right. Now, let's figure out what the antiderivative is. Well, what am I going to have to take the derivative of to get x to the 1/2? Well, I know it has to be x to the 3/2, right? Because think about this. Whenever I bring the 3/2 down, right, if I'm taking the derivative of this, I bring the 3/2 down, minus 1. So 3/2 minus 1 gives me the 1/2. Okay? Now, what about the number in front? 3/2 times what number is going to give me this 1 here? Well, 3/2 times 2/3. You see that? All right, and then I've got minus. Now, what about this one? I've got x, right? What is the exponent going to be here? I've got to take the derivative of x to the what? And I need a negative 3 for my exponent. Well, that's x to the negative 2, right? X to the negative 2. Because remember, if I take the derivative of this, the negative 2 comes down, right? The negative 2 comes down, subtract 1 from the exponent. Negative 2 minus 1 is the negative 3. But I need a number. What number do I need right here? Well, let's see. I've got negative 2 times what? Well, that's going to be negative 1, right? Because negative 2 times negative 1 gives me the positive 2. But notice, there's my minus sign. See, so I've got negative 2 times negative 1. So this is going to be 2/3 x to the 3/2 plus x to the negative 2. All right, and so that would give me 2/3 x to the 3/2 plus 1 over x squared. And there's my antiderivative. Okay, so, so far the numbers that were, the functions that we're taking the antiderivative of, it's not that bad. Okay, we're just kind of thinking backwards, right? Remember, the antiderivative, what function do I need to take the derivative of to get, whatever function they give me? Now, they can get more difficult, like this one, for example. What do I take the derivative of to get this? And I need to correct this. This should be a squared right there. That should be a squared. All right. So let's look at this. So I know this part of it right here. Okay. We're looking at chain rule right? When we're taking derivatives of something in parentheses raised to a power, well, I know that needs to be x cubed minus 1 cubed, right? All right. So now, what's going on here? Let's just go through the process of taking the derivative of this thing. The 3 comes down, right? If I'm taking the derivative, the 3 comes down, and what do? I subtract 1 from the exponent. All right, there's that part. And then remember the chain rule, then I multiply times the derivative of what's inside the parentheses. So the derivative of that is 3x squared. Well, look at that. I took the derivative of this, and it gave me this function here. So this is my antiderivative. Now, what I want you to understand here is if this right here is just kind of, whoa, I'm not getting this. I'm not sure I would be able to just look at a function and say, okay, what do I need to take the derivative of to get that? Don't worry about it, okay? Don't stress about it, because like I said, in the next several videos, I'm gonna show you techniques, power rule. We're gonna learn U substitution. That would be, this problem here would be U substitution. Basically, what I'm getting at is when you're doing antiderivatives, you're not really gonna be working them like we're doing in this video. This video is just to get you to understand what the antiderivatives are, okay? And this is applied calculus class, okay? If you're taking a calculus, not applied calculus, but calculus, and you're looking for the antiderivatives, I've got a video on that. Just not Google, but search my YouTube channel, Calculus Antiderivatives. In that video, it's kind of like this one, but it goes into more detail, okay? And even if you're in the applied calculus class and you want to see more detail, then watch that video. You may not understand some of it, because in the calculus class, there will be some trig functions thrown in there. But as far as applied calculus goes, this is all we've learned so far, is taking derivatives of polynomials. We haven't got into the trig stuff yet. So, but yeah. All right, and then this is the last one. So find the antiderivative of this function, okay? So, pause the video and see if you can work it. All right, so first thing, let's just look at it. 2x plus 1, and then that's to the 3/2, right? Because remember, when we take the derivative, the 3/2 comes down, right? The 3/2 comes down. Subtract 1. What's 3/2 minus 1? That gives us our 1/2 right here. Well, let's go on and take the derivative of this thing and see what we get. So 3/2 times 2x plus 1 to the 1/2 times the derivative of what's inside the parentheses. So that's times 2. And so that would actually give me 3 times 2x plus 1 to the 1/2. All right. So you see, when I took the derivative of this, I end up with this right here. But that's not what I want. See, this problem here doesn't have a 3 in front of it, does it? You see that? It doesn't have a 3 in front. So what can we do to get rid of that 3? Well, if we multiply it by 1/3, that gets rid of it. So we would need a 1/3 here, and that would be our antiderivative. And keep in mind that this is just a basic overview of antiderivatives, okay? It's just here's the concept of it. That's what we're doing in this section, okay? And remember what I said earlier about the plus c, plus a constant term. You will have to put the plus c in front of them. I mean, behind it like that. Because, you can have some constant out here. So if I took the derivative of this and there was a number here, I would still get this as my answer if I took the derivative of all of this because the derivative of a constant is 0. Okay? And that's normally what I show when I do antiderivatives. You do the plus c. I'm not doing it here because the book that I'm teaching out of, they mention it like I'm mentioning it now. They don't put the plus c with the problem. I'm not sure why, but they don't. But just keep in mind that this is the antiderivative with a plus c. And I could come back up here and I could add the plus c to all of them, and it would be correct. Okay? And like I said, in the rest of the videos, we'll always have that plus c on there because it is plus some constant. And that'll be one of the first things I discuss in the next video. So, this right here, just to give you an idea, and in the next videos when we're really going to hit the antiderivatives on, okay, this how do you do integrals? Okay, we'll be doing indefinite integrals, definite integrals, all that good stuff in the next several videos. So I hope you enjoyed it. And like I said, if this kind of, I don't really understand what's going on, watch the next one, and I'm going to give you, okay, here's the procedure for integrating. And you're going to be able to integrate anything, okay? You're not going to be doing like this where, okay, you're not going to be working them like I did in this video. This video is just, okay, here you go. These are antiderivatives. But next video, I'm going to show you really how to do them. So hope you enjoyed it. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see you in the next one. Later.